Yeah.
Aurelia won't be presenting. I'll be presenting on her behalf for this paper.
Okay, Raphael.
Yep. Okay. So, alright. Good afternoon, everyone. I'm Raphael Reynaldi, and today I'll be presenting our paper titled Sentiment Analysis Model to Boost Up Bitcoin Prices with Selected Tweets. And my team consists of my lecturer, Ms. Nunung Nurul Komaria, and alongside my peers, Ardila Shala Araminta and Sri Kalian Rohan. So for our data set, we took two data sets, one from Kaggle and one from Yahoo Finance. The one from Kaggle is web scraped data of Twitter tweets, and the other is the price action of Bitcoin. Both data set consist of around 1.5 million data, but we wanted to be more specific with what we were trying to create with our model. So we scraped around 10,000 data, and in that 10,000 data, there was the price action that started from around March 2020, so around the start of COVID, or like the height of COVID kind of thing, till the end of 2021. And then for our Kaggle, we also decided to scrape the amount of followers to 2,000 and above, because if we didn't want our model to be influenced by Twitter accounts with smaller followers. And then the final attributes that we also added were text, so we into our Yahoo Finance data set, so we were able to get the actual UTF data of the tweet, and then fluct, which indicates the fluctuation of the price on that day. So whether it be an increase in price or a decrease in price. Our pre-processing, we first remove special characters and non-values. After that, we turn all characters to lowercase and filter attributes used for the classification model. And then after that, we tokenize and vectorize those phrases or attributes. Our embedding technique, we use the term frequency inverse document. So essentially, it takes a given term and the frequency of that term within a document, and then see how it correlates with the other selected terms within the document. So say, for example, the word cryptocurrency, and it compares it with maybe price action or another phrase essentially within a document. With that, our model, we used support vector machine, SVM, and capable validation. They're able to run simultaneously on top of each other, and we were able to create our final hyperparameters were C with a value of 10, gamma with a value of 1, and kernel with a value of RBF. And then these are our results. So on the left, there's the ROC curve for our SVM model, and on the right is our accuracy scores and precision scores. I'd like to bring the attention to our support value. As you can see, it's equal to one another, 1,103, which means that our data is balanced, which helps further support the reliability and accuracy of our model. We achieved an accuracy score of 77% alongside the precision score as well for the fall in price. And then the rise in price, we achieved a precision score of 78%. Here are our findings. So on the left side is a more visual representation of all the words that have that affect the price of Bitcoin on that certain within that certain time period that we set. And on the right is a more general graph, or general graph. As the top 5 words are opening ceremony, Olympic Games, B word event, and then there's BDE and BTO, and then also the B word. Essentially, these are what affected the price on a given day. So whether it be a decrease in price and an increase in price. And opening ceremony had the most weight out of all the words. So in conclusion, we were able to create a model which was able to essentially correlate the price action of Bitcoin alongside certain weighted words, and also classify the scraped Twitter tweets that we use for our dataset. With that, thank you everyone for listening to the presentation.
Okay, and thank you for Mr. Raphael from Bina Nusantara University.